heavy end stripper in the outlet of the total distillation column. Conventionally, it is a still with a very high residence time. It can be changed to a rising film post stripper with same benefits. Excuse me. Excuse me. Select anything. हाँ, ठीक है, ओके। नो प्रॉब्लम। Thank you. No, no, it's okay. Only thing is I cannot see. So, somebody is doing something. Okay, so sorry for the interruption. So to commence back in the glycerin distillation section, there can be two Kaizen points. One, the pump around loop of the glycerin distillation section has a lot of heat, and that heat can be used in the deaerator, and this can lead to approximately 200 kgs per ton of feed savings in the steam. Similarly, for the pitches of the glycerin distillation, if we use a wide film evaporator, we can get a reduction in the glycerin loss up to 2%. Advanced vacuum systems, which are also today implemented in a large scale in refinery, are also applicable for fatty acid distillation plants and glycerin distillation plants. We will see some examples in the refinery slides. Within the edible oil refinery, if we go to various processes in the water degumming, the typical water degumming flow sheet is like this. starting from the bulk tank, day tank, the heat exchangers to heat the oil, water mixing, hydration, separation of the gums. These conventional plants can be upgraded by adding a mass flow meter in the inlet to improve the yield measurement, adding the side entry agitators in the bulk tank, which is very important to have a homogeneous oil coming to the plant. So a side entry agitator can greatly help. A automation of the water dosing system with respect to the oil flow, a proper measurement of the water flow itself by electromagnetic flow meter, improving the separator reliability by a magnetic strainer. These are the simple measures which can improve the water degumming section. Similarly, one of the Kaizen points when the water degumming section is used to produce lecithin is to have a crude oil filtration section upstream of the water degumming section, which can improve the hexane insolubles in the lecithin. One approach also can be to use a nanocavitation based mixer for the water and oil, and this along with a dual temperature hydration and then separation has been known to increase the lecithin yield by around 0.2%. Similarly, in the neutralization and washing, we see a conventional flow sheet of neutralization and washing. It is the crude oil tank, the heat exchangers, a phosphoric acid mixing, acid reaction, caustic mixing, caustic reaction, separator for soap separation, heating, and then the soap washing, hot water addition, and the wash water separation. The conventional neutralization section can be improved by adding mass flow meters for yield measurement. The largest percentage of loss in any chemical refinery will happen in the neutralizing section. So the yield measurement in the neutralizing section will definitely help to control the losses. We can improve the mixer for the phosphoric acid to high shear mixers. We can completely automate the chemical dosing systems. The caustic soda dilution, which is many times done manual, can be done online, automated. It is also helpful for especially lower quality crude oils to then cool the oil after acid reaction to around 50 degrees, have the caustic reaction at 50 degrees and reheat the oil at 85 degrees before separation, like a classic long mix. Magnetic strainers in the inlet of the separator, self-cleaning separators definitely help. We can improve the heat recovery by recovering heat from the deodorized oil before washing, because neutralization, soap separation normally happens at 80, but the washing is done at 95. This heat can come from the deodorized oil instead of consuming 15 kg per ton of steam. The washing itself is becoming obsolete now, but if the washing needs to be done, we can go for a wash water recycle system, and pH of this wash water recycle also can be reduced by various measures to improve the efficiency of the washing. The wash water recycle can reduce the wash water consumption from 10% to 5%. This is an example of a improved dynamic mixer for phosphoric acid mixing. The automation of the chemical reagent dosing for small plants, we can just have a small dosing pump, a manual, and then there is a manual preparation of the caustic soda solution, but then if it is automated, we can just have an online dilution and control of dosing together. These are typical examples of the flow meters. The electromagnetic flow meters are quite accurate, very useful for chemicals, hot water, phosphoric acid, caustic soda. Mass flow meters for the yield measurement of the oil. They can come at an accuracy of even 0.05%. Typical examples of the SCADA systems for the automation of the refineries. And the chemical dosing, the key of the neutralization is chemical dosing. This can be completely controlled by a menu-driven system in the SCADA. Similarly, another advancement in the neutralization is a nano-cavitation-based nano-neutralization. So nano 2G modules can be added for the acid mixing and for the caustic soda mixing. The nano-cavitation has distinct advantages. It has actually broken a technical barrier which was there in the neutralization process, that for long period of time we were using high amount of phosphoric acid, much more than the stoichiometric requirement, and this has been reduced by the nano-cavitation. So the nano-cavitation, the energy which is released on the molecular level ensures that the phosphoric acid consumption can be reduced to the stoichiometric levels, and this itself then gives multiple benefits. The phosphoric acid consumption comes to 0.3 kg per ton. Even for a soybean oil, it immediately reduces the caustic consumption. The excess caustic dosage reduces because we don't need any more excess caustic to stabilize the separation. The soap ppm in the outlet of the separator is low. If we are doing silica treatment instead of washing, we can use 50% less silica. And the oil yield increases by 0.2%, which is the most important gain because we do not have any more saponification losses by the excess caustic. The typical payback of the nano-neutralization for a 200 ton plant can be typically 148 lakhs per year. Bleaching section, the flow sheet of the bleaching, conventional bleaching section, the inlet tank cum vacuum dryer, the plate heat exchangers for heating, the bleaching earth mixer, the bleacher itself, the pressure leaf filter, and the big slope oil tank to handle the slope oil from the pressure leaf filter, which is the dirtiest part of the plant. The improvements in the bleaching section, if we look into the Kaizen measures, it can start from the pressure leaf filter itself, it can be automated. The blowing steam of the pressure leaf filter need not produce slope oil, there can be a smart cyclone there. So the slope oil from the plant can be completely eliminated. And the blowing steam can be completely condensed, so that nuisance of odor and that dirt outside the plant is completely eliminated. We can improve the safety of the PLF by a press bleach system. Similarly, washing can be entirely eliminated by a silica pretreatment section, which actually is already implemented in many plants, but there is still scope to implement the same. One important thing is the vacuum sealing system. Like we see now, there are frequent power failures in the plants also, and every power failure leads to loss of vacuum, which can be avoided by a vacuum sealing system, which are basically the on-off valves in the steam and the spark steam and the cooling water lines, which seal the vacuum in a standstill condition. The examples of the Kaizen in bleaching, we can have improved bleaching at dosing systems, very rugged constructions. They can be, one system can be spare always, they can be isolated for cleaning. Small things, but they can give good value. The on-off valves which are there for the pressure leaf filter automation, just an example photograph, a SCADA snapshot of that. One important thing is, one of the most expensive input to refining is the bleaching earth, in terms of the cost also and in terms of the effluent as a solid effluent. And bleaching is a co-current process today. The neutral oil and the fresh bleaching earth mixes together and the bleached oil and the spent earth is separated. This kind of an arrangement leads to this spent earth having a residual bleachability, and a pre-filtration targets to utilize that bleachability and leads to 5 to 10% savings straight away in the bleaching earth consumption. The pre-filtration needs one more filter. So after the filtration has built up a spent earth layer, then it goes to a pre-filtration step where the feed neutral oil is passed through that to extract the bleachability. Deodorization, yes, a simple deodorization section, can be in many configurations, but yes, typically the heating tray, the deodorizing trays, the internal heat recovery tray, the scrubber, the deaerator, of course the 4-stage vacuum system very typically as we see, and of course the cooling of the deodorized oil. The Kaizen points in that, the most important point can be the vacuum sealing system. The deodorizer works under very low absolute pressure. Every power failure, if we are losing vacuum in that, it is a loss of oil quality. A vacuum sealing system can simply eliminate this nuisance. Similarly, most of the plants now actively do vitamin dosing. This can be completely automated by a dosing system. The spark steam comes with a lot of impurities from the boiler end, and if we have a spark steam filter, it can help to keep the deodorizer spark steam coils clean for a long period of time. The typical example of a spark steam filter, which is a wedge wire based. This is an example of a vacuum sealing system where the barometric water is provided with on-off valves. This is an example where a high pressure steam is provided with on-off valves to close in case of power failure. Within the deodorizer can also be improved for capacity expansion straight away, control of trans fatty acids, which is the current regulation, and upgrade to quick feedstock chain system. Typical example, I will not go into the details, but addition of a simple stripper can reduce the motive steam and open steam consumption, can improve the PFID of fatty acids, can also improve the capacity of this plant by 20–30% very easily. Similarly, a external oil-to-oil heat exchanger, if it is added to a conventional deodorizer, we can run the deodorizer as a dual temperature deodorization. So typically 15 minutes we can run at 245 to 250 degrees. 45 minutes we can run at 230 degrees, and we can control our trans. We can also, if there are multiple products to be run in a continuous deodorizer, it is always a challenge to take this product changeover and minimizing the inter-product mixing. This system can be used to completely automate that. So we can have a startup heater. Each deodorizing tray can have on-off drain valves and high-level and low-level switches. And a PLC sequence can be built to do this feedstock change automatically. All lines can be provided with nitrogen or steam flushing, as the case may be. Within the advanced vacuum system, we have two options. One is the chill barometric water system. The chill barometric water system, instead of operating the conventional vacuum system at 34 degrees, we can operate it at just 5 degrees. And this reduces the steam consumption drastically. But this barometric water needs to be cleaned, so there are 2 pHs or more pHs, and one pHe is in cleaning mode, but other pHs are in operation. And in this pHs, this barometric water is cooled from 10 degree to 5 degree using a glycol water. The overflow barometric water from the circuit goes to a fat trap, where any traces of fatty matter can be separated, and the whole system can be maintained alkaline, which is important, otherwise it can be an odor issue. It can be maintained alkaline by dosing of caustic soda. And while this is done, the bleaching vacuum system can be converted easily to shell and tube type. So entirely the barometric cooling tower from the plant itself can be eliminated. The ice condensing system is a further step in that. In the ice condensing system, the spark steam which is coming from the deodorizer is cooled by liquid ammonia in a specially designed shell and tube condenser. And inside the tubes, the ammonia is being circulated. Outside the tubes, the spark steam actually freezes into ice. And what goes to the vacuum system is only the air load of the deodorizer, which is saturated by the moisture. So the vacuum system actually becomes only a deaeration group. Although it appears to be a 4-stage system, it is a system designed for much lower load. And drastically, the steam and power consumption of this system is reduced. So it has an ammonia chilling system, so ammonia chiller in that, which is a critical component in that. And also these shell and tube heat exchangers, what we call typically sublimators, they operate in tandem. So one is in operation, one is in freezing, and there are high performance butterfly valves in that. There are safety systems in that. An advanced system needs advanced care. We have recently commissioned one system here in Kanpur Edible. So it's an example of this particular upgrade. So comparison of this vacuum system, if we compare for a 600 tons per day deodorizer, a typical conventional vacuum system will consume 86 kg per ton of steam and 3.9 units of power for the barometric cooling tower. But a mixing condenser with chill barometric water system, it can reduce from 86 to 32, and power will increase from 3.9 to 16.5. But the barometric cooling tower is eliminated in this. The ice condensing system is even extreme. It can reduce this 86 kg per ton steam, motive steam, to only 8 kg per ton. And even the power requirement is very low. It is only 7.3 units. So these are the advantages of these advanced vacuum systems, which are quite relevant today. They are also environmental friendly because they eliminate the odor pollution and the effluent from the barometric cooling tower. So advanced automation system, yes, automation, a lot of plants are automated. Conventionally, they do process control, but they can be used for the losses measurement also by series of flow meters and also by automatically measuring the work in progress. They can also be used proactively for plant and product safety, as we see the vacuum sealing system example. Most importantly, we can also now integrate the QA system of the plant to the plant log sheet. So the laboratory data generated by the QA lab can be automatically updated into the plant log sheet, thus linking it to the process parameters, and this can develop a lot of data which can be then used for the guidance, future guidance of the plant operation. The modern automation also comes with network features. It can be networked to the MIS systems. There is a facility to remote viewing of the SCADA in the head office of the client or in the plant manager's office. There are portable SCADA systems. The operator can take them to the plant. There can be a remote service available for that. There is no need for a software engineer to take a flight to the plant. He can operate it from remote and service that SCADA. So thank you. I acknowledge my colleague P. Srinivas Rao for the oleochemical part. He has helped me in that.
If there is any question to the speaker, you may kindly ask. Mike.
Hello. At present, everybody is facing the problem of the high chlorophyll in the soybean oil. So whether this nanotechnology help in that, because it is phosphoric mixing is more better than the normal.
One thing is sure that the nano cavitation reactor is a very efficient reactor for phosphoric acid mixing as well as the acid mixing. What we have observed is that for the chlorophyll control, it is the acidity what we induce into the system which helps us to remove the chlorophyll. So we generally have to go for higher phosphoric acid, and that of course has to be neutralized. So this phosphoric acid mixing definitely is better. We don't have a direct data how it behaves in a high chlorophyll soybean oil, but it is running on soybean oil in many plants. So and these same problems are there. So, and even in those plants, maximum phosphoric acid dosing, what we observe is 0.4 kg per ton. But 10,000, 12,000 chlorophyll is still available there. So it's
Final
seems
oil
to be
color,
in
any
control,
data
yes.
about the final oil color are you getting in the 8 unit, 10 unit, like soybean standard is 8 to 10 unit maximum. So is there any data available with you?
Final oil color for those high chlorophyll oils, yeah, people maintain between 10, 11 units. So it is different for different standards, but it is maintained 10 to 11 units.
One more question about the long mix. Long mix you have mentioned, first we are cooling the oil 50 degrees Celsius, then again heating 90 degree. So there is a considerable heat loss. Ultimately we are using steam.
It's a very simplified flow sheet, but we can actually add a heat recovery heat exchanger in that. So while it is cooling,
Still we are also having long mix in Kandla.
yes,
We
yes,
have
but,
to heat.
but we can improve that. Actually, we had okay. We'll discuss that later. But we can add sufficient heat recovery heat exchangers, and we can eliminate the impact of the utilities from that. But it's a very helpful process, especially we are having difficult oils. The neutralizing the caustic reaction at a lower temperature and reheating them, that is a very helpful step.
As a Kaizen, why you do not recommend the soap off instead of washing? You can save the water, soap water, wash
Yes,
water.
I presented it. The silica pretreatment is supposed to eliminate washing.
Thank you.
Many people don't like it, but on port, all of us have done that.
Thank you,
Yes.
Mr. Shrivastava.
Thank you.
Thank you.
Anybody else? Yeah. Prabhat ji has a question.
Thank you so much, sir. As a token of our
There's a question.
Atul, I saw this presentation which a lot of automation is talked about. Just I want to know your experience.
Can't hear you. Sorry.
Hello, can you hear me?
Yeah.
Yeah. I'm saying in the presentation you have shown a lot of automation in the refining side, bleaching and deo side. What is your experience, especially on the chemical dosing? How frequently our customers are buying automatic online dosing systems? What's your experience?
Yes, we do it as a part of customer service initiatives for some plants, and definitely there is awareness in the industry for that. One of our clients actually remarked to me that neutralization is nothing but a game of accurate measurement of reagents.
Absolutely.
You measure caustic soda, you measure phosphoric acid, you measure water, and that gives you a very, very effective neutralization.
Yeah, perfectly in the align what you are saying, but I just want to know your experience. Are you getting more and more inquiries for these kind of automations? what is it? What is the trend in dismet?
These are already available in the new plants.
On the new plants.
Only the legacy plants, they upgrade to this.
Okay.
Where these systems were manual at that stage, and where that time, 20 years ago, there was a lot of hesitation to go for a PLC based plant. Now even the air compressor comes with a PLC, small one. So
Yes.
there is nothing special about a PLC now. So now there is an acceptance to that technology, and yes, now people accept it. But 20 years ago, there was a resistance. People were saying, I am in a remote area, how will you service it? All those questions are now settled. So now people accept it.
That means we can say now it's a standard norm in the refining business. People are buying all these automated dosing, controls, loss monitoring systems. So it's a standard now as we speak.
Yes, yes, it is quite standard. Now in the new plant, it is quite standard. That is what I said. The Kaizen is important for the legacy plants to compete with the new plants. Otherwise, they will be phased out. So,
Thank you,
Prabha-
Atul.
Prabhaji, speaker will be here, so you can personally discuss it with also. Thank you.
okay.
Thank you, Mr. Joshi. So, in all, we had 5 lectures, 2 from the BIS, 1 from Fair Lab, 1 from Unilever, and the other from Dismet. BIS speakers have clearly, said that how they can help you in formulating MOU, and they discussed about the various committees which are existing in BIS, and how you can participate in BIS and can take advantage of ISO committee, which is for international standards. So one was speaking for in general. The other speaker talked about the formulation of specifications for oleochemicals, which can help in sustainability program. Then Dr. Y.P. Singh from Fair Lab, he spoke on critical elements for maintaining quality standards in food and oil industry. He mentioned about the requirements for that and what are the things which we should look for, like accreditation by NABL, then other accreditations, international accreditations are required so that the material could be tested for say minor elements also, and you can see that the food is safe. Then Dr. Sudipta Ghosh Dastar, he discussed about material efficient soap bar materials efficiency in skin bars and liquids. He discussed something about the formulations also, that how they form, probably they were using enzyme or microenzymes. And then he discussed about NDP also, that is no deforestation, no peat, no exploitation policy. It is for palm oil. Just like this, there is another policy of round, RPSO. So it's similar to that. So if one is following this policy, that means that the product which is coming is of very good quality. Then Atul Joshi ji has spoken about Kaizen approach for upgradation of the existing vegetable oil refining unit. So he discussed right from beginning that how we can bring the changes in degumming, in bleaching, in deodorization, and how can we say we can change the combination of the bleaching earths also, and thus we can have better efficiency and better quality of the oil too by using lesser quantity. And also he explained about the importance of automation, which is to be used in vegetable oil industry, so that you can get everywhere you can get process efficiency. So that is all was there in the 5 lectures held in the evening. All were very nice lectures, and I am sure that everybody would have been benefited by their talk. So let us give them a big round of applause for their nice talk.
I would like to, on behalf of the chairs of the session, as well as on behalf of the organizing committee of this conference, express our gratitude to all the speakers, Mr. Ajay Kumar Lal, Mr. Virendra Singh, Mr. Atul Joshi. The audience which are available here. Secondly, we are grateful to the audience who have been constantly listening to these talks, and without that this could not have been possible for the interaction during the conference. Last but not the least, it's our pleasure and to express gratitude to Dr. R.P. Singh, the chair of the session, on behalf of the organizing committee. And finally, we are grateful to the organizers who gave this, who assigned this task to us for conducting this session on time. Thank you so much.
Thank you so much, sir. Now, as a token of our appreciation and gratitude, we would now like to facilitate with the memento. I request Professor R.P. Singh, sir, to kindly present the memento to Mr. Sudeepta Ghosh Dastidar, sir. Next, I request Dr. H.B. Singh, sir, to kindly present the memento to Mr. Atul Joshi, sir. Now, I request the chairman of Oleocon, Dr. Praveen Yadav, sir, to kindly present the memento to our co-chairperson, Dr. H.B. Singh, sir. Next, I request Praveen Yadav, sir, to kindly present the memento to our chairperson, Professor R.P. Singh, sir.
Thank you, sirs. I would like to request you all to please come forward for a group photograph. Bring it, sir. Thank you so much, everyone. With an end to the second session, we would also like to thank our sponsors for OleoCon 2025, supporting and collaborating organizers, IVPA, Fair Labs Private Limited, BIS. Event sponsors, Kanpur Edibles Private Limited. Platinum sponsor, Unilever. Kit sponsor, Sachi. Gold sponsor, Desmet, Dinesh Sahara Foundation, RSPL, Creative Engineers and Consultants, Crystol. Silver sponsors, Godrej, Shirdi Sai Nutraceuticals Private Limited, Novonesis, and Patanjali. High tea sponsor, Mandor Oil Product Private Limited, Vital Home Care. Lunch sponsor, Shielchand Agro Oils Private Limited. Exhibitors, Desmet, Global Active Clay LLP, Volsante, Creative Engineers and Consultants, Shirdi Sai Nutraceuticals Private Limited. Thank you so much everyone for giving your time. Now please proceed for high tea.